Happy 2019 to the best physics students in the world. Now, since I won't be able to be with you guys this week, I'm going to be posting this lesson online so that you can watch it in class or you can watch it at home so you can go back over the examples and go back over the lesson. So the title of this new lesson is going to be called Electric Fields. And the symbol for electric fields is E. Now, before I go on with electric fields, let's take a recap. So some things that we've learned are that we can charge two things by two different methods. We can charge things by something called conduction. Where with conduction, if you touch a charged object to a neutral object, those electrons are going to flow from that first object into the second object. So the key thing is that the two objects have to touch so that you can have that transfer of electrons. So this one's by touch. The second way to charge something is by induction. What induction is, it's when you hold an object close to another object and there's no transfer of electrons, but the electrons in the second object will move or shift their location within that object. And that's called polarization. So let's say I have a neutral object and then I have a negatively charged object. What's going to happen is if I put this negatively charged object near this neutral object, all the electrons on this side are going to flow to that side of the object because remember, the electrons want to get as far away from each other as possible. So this is going to happen. So now all the like charges are far away and all the opposite charges are closer together. Likewise, excuse me, if you have a positively charged object, all the electrons are going to flow towards the positive. So now all your electrons are going to be over here in the neutral object, and all the positive is going to be over here. That's if we have a positive rod. And all this goes back to the foundational skill of opposites attract and likes repel. So we started off talking about conduction, induction, and attraction and repulsion. Then we went on to talk about electrical force. And with electrical force, we learned that the equation that describes electrical force is called Coulomb's law. Coulomb's law. And what that tells me is electrical force is equal to K, which is a constant, times the absolute value of the two charges multiplied divided by the distance squared. Remember, F is electrical force. K is a constant, and it's going to be 8.99 times 10 to the ninth. I'm going to put my units in. So this is the units for that are Newton meters squared per Coulomb squared. And then Q1 is charge 1. Q2 is charge 2. And remember that the unit for charge is coulombs. So it's just going to be C. And then R is the distance between the two charges. And that's going to be in meters. So if I have charge 1 and I have charge 2, and I know the distance in between them, I can measure the force in between these two charges. So rewriting that, I know F is equal to K, Q1, Q2, divided by R squared. Now there's a few things that I want to go over. If I wanted to solve for R, what I could do is cross multiply and then divide and take the square root. So R, and you can try this at home, R is equal to this equation right here. In addition, if I wanted to find the two charges and they're the same, I can rewrite this as F is equal to K Q squared divided by R squared. If they're the same, because Q2 is Q1 or Q1 is Q2. So I can just write Q squared. And then Q, so if I want to find the value of that charge, it would be this equation. And then last but not least, because we did see one tricky problem where it said one charge is double the other charge. So if one charge is double the other charge, I can write Q1 is equal to 2 Q2, or I can write Q2 is equal to 2 Q1. This says equals 2 Q1. So if I plug this in for Q1 into that equation, what I'll get is, and let me just box in all my equations. So this is like my main equation. And then I can have these supporting equations. So then I would get F is equal to K. But remember, Q1 is 2Q2. So I can write 2Q2. Then I would have this Q2 all over R squared. Now solving for Q2, I'll get so Q2 would be equal to FR squared divided by 2K then take the square root of that. And then to find Q1, I can just plug this back into there. So that was Coulomb's law. It was pretty easy. You guys did really well on your Coulomb's law quizzes, which I'm really impressed about. So all of this is what we've learned before. We've learned conduction, induction, and Coulomb's law. But back to electric fields.